Here we are going to do a few important reactions of phenol, important reactions of phenol, which are repeatedly asked in the past papers. Okay, guys, these reactions are important and you need to know each and every reaction. Okay, the first reaction is reaction of phenol with metals. So, reaction with metals. In the previous video that we did, we learned that phenol is acidic in nature, and acids, when react with metals, generally they give off a salt and hydrogen gas. So same is the case with phenol. When phenol is reacted with a reactive metal, for example sodium, it gives off sodium phenoxide salt plus hydrogen gas, half mole of hydrogen gas. Okay, so this is the first reaction. Then the second reaction is reaction of phenol with alkalis. So the second reaction is basically the reaction of phenol with alkalis. So since we know that phenol is acidic in nature, and generally when alkalis react with acids they give off salt and water as the product. So phenol plus alkali is that I'm using is sodium hydroxide. The product is again the same salt, sodium phenoxide, O negative Na positive, plus water as the byproduct. Then the third reaction that we are gonna look at is the reaction. Basically, it's not reaction; it's basically the acidic behavior of phenol in water. If we dissolve phenol in water, basically we have our phenol over here, and it is dissolved. It is basically added to water molecule. So phenol, being acidic, dissociates, producing the phenoxide ion and H positive ions. Okay, so phenol is basically acidic. Actually, not H positive. It's hydroxonium ion that it produces, H3O positive. This ion is known as hydroxonium ion, or also called the hydronium ion. Hydronium ion. Okay, so basically phenol, when dissolves in water, it gives all of H3O positive. I've made the hydronium ion because in this equation I've used water over here. If the water wasn't used and rather only aqueous was written over here, phenol when dissolved in aqueous solution, then we would have written phenoxide ion and H positive ions, aqueous. Aqueous. Okay, so it basically means the same thing, hydronium and hydrogen positive ions, uh, just different ways of representing the same concept. If water is the reactant, then the product becomes H3O positive. If the aqueous solution is written as the reactant, then H positive is given off as the product. It's not a big deal, both of them are equally acceptable. Okay, the common name of phenol is carbolic acid. Phenol is also known as carbolic acid. Okay, this is a common name of phenol. Uh, okay, and phenol, when dissolved in water, it basically gives a pH of approximately 5.4. So this is weakly acidic solution, and we've talked about it in the previous video that phenol is a weakly acidic solution because its pH is just below 7. So it's near 7 actually. Okay, then let's do another reaction of phenol, an important reaction again. uh, what if we add phenol to sodium carbonate, Na2CO3? Sodium carbonate Sodium carbonate is generally used as a test for acids. Test for acids, right? Because it gives off carbon dioxide on reacting with acids. But when we react it with phenol, there is no reaction at all. So this proves that sodium carbonate, phenol is not as strong an acid so that it could react with sodium carbonate. That's why sodium carbonate has no reaction with phenol, and similarly, as we've seen in the previous video, that ethanol or any alcohol, when basically reacts with sodium carbonate, it also gives no reaction. Why doesn't ethanol give any reaction with sodium carbonate? That's because ethanol is even a weaker acid compared to phenol. Ethanol is a weaker acid compared to phenol. We've talked about this in great detail in the previous video. And ethanol is less acidic. It is a weaker acid compared to phenol. That's why it won't react with sodium carbonate, because the phenol itself cannot react with sodium carbonate. So that's why sodium carbonate is always considered the best test for acids. Any acid, whether they are organic acids or the mineral acids, for example hydrochloric acid or nitric acid or sulfuric acid, any acid will give a positive test with sodium carbonate. Ethanoic acid will give a positive test with sodium carbonate. All the acids will give a positive test for sodium with sodium carbonate, but neither the ethanol nor does the phenol give a positive test with sodium carbonate. Although they are acidic, but they are very weakly acidic. Okay, now let's go on to some more important reactions of phenol. The electrophilic substitution reactions of phenol. Electrophilic, the first reaction that we are going to do is reaction of phenol with concentrated nitric acid and dilute nitric acid. First, let's talk about dilute nitric acid. Dilute H2SO4, dilute H2SO4, dilute, and room temperature and pressure. So as you can see, these are very mild conditions, that they are not concentrated and the temperature is not 55 degrees Celsius and not under reflux, but rather just the room temperature. At room temperature, since phenol is a very strong activating group, it is a very good activating group. It activates the benzene ring to react with these with the dilute with the mild conditions, and as a result, and we know that OH groups are 2,4,6 directing because it's an activating group and the lone pairs are present on the oxygen. So the nitric acid over here is our nitrating agent. It will give the nitronium ion as the electrophile. The electrophile will go on and attack the second carbon and the fourth carbon of phenol. So as a result, we get two products in equal quantity, and both of them are positional isomers of each other. The first product that we get is 2-nitrophenol, and the second product that we get is 4-nitrophenol, and they are both in equal quantity. They are in a 1-to-1 ratio. Then the next reaction, okay guys, it's important, this is the only reaction where the nitric acid and sulfuric acid are used in the dilute form and the temperature is RTP. This is the only reaction with benzene compounds that is possible. In all the other reactions, these two reagents are used in concentrated form.